Hi everyone, this is Ms. Moriarty and I'm here to discuss with us topic 9.1 as well as 9.2. Don't forget, as you watch the video, you want to make sure that you are taking down notes and marking this as done when complete. So here we go. So the first part of our Unit 9, which is all about global change. And remember, guys, it's actually Unit 9 should appear on our AP exam a little bit more versus all of the other units in terms of percentage where we see in the questions. So here we go. In topic 9.1, this is all about stratospheric ozone depletion. If you can remember, back in Unit 7, we talked about tropospheric ozone. That is bad ozone, right? That is ozone that we don't want being produced, especially in the area of the atmosphere in which we live. However, thinking back to Unit 4, in the layer of the atmosphere known as the stratosphere, that is the ozone layer, right? That's the good ozone. That's the ozone that we want. And it's the ozone layer that we know that's incredibly important to the evolution of life on Earth and the continued health and survival of that life we find on Earth. Now, the main purpose of the ozone layer is to block UV light, UVA, B, and C. And a decrease in the stratospheric ozone we know is going to increase the UV rays that are going to reach Earth's surface. And if that were to occur, exposure to UV rays can lead to a greater instance of skin cancer as well as cataracts in humans. Now, it's important to understand not only the depletion of stratospheric ozone, but also the formation, because the depletion and formation actually happen naturally in the stratosphere, and it's a actual balanced equation that we can see here. So if we have oxygen molecules, we know that those are going to be split due to those UV rays, and that's actually how it absorbs it. And then that oxygen molecule is split into two atoms of oxygen, and it's that one atom of oxygen that then reacts with the oxygen molecule to form our ozone, or O3. And so we can see that this breaking down and forming of stratospheric ozone happens all the time, and it should happen in equilibrium. But what we see now happening is anthropogenic ozone depletion, meaning human-influenced ozone depletion, which is going to cause what we know as the ozone hole. Now, what causes that anthropogenic depletion is a substance known as CFCs, or chlorofluorocarbons. They are primarily due to then human use, and it's going to cause the breakdown of O3. Now, CFCs were used as refrigerant chemicals and propellants in aerosol containers back in around the 50s, 60s or so, and we found those in hairsprays and Febreze. But the main reason why we don't want CFCs anymore is because the UV radiation causes free chlorine atoms to separate from the chlorofluorocarbon. Because chlorine is a highly electronegative atom, it's going to bond to one of the oxygen atoms of ozone, ripping it right from the O3 and converting it into an oxygen molecule, or O2. Then that free oxygen atom then bonds to form chlorine monoxide, and eventually to form O2 and a free chlorine atom once again, to then further continuing the breakdown of the ozone layer, or O3. And we can kind of see that in the image that we have here, right? We know CFCs are going to be released. They rise into the stratosphere. The UV releases the chlorine from those CFCs there. The chlorine is going to destroy ozone over time. We deplete the ozone layer. More UV radiation gets let in, and more UV is going to cause more skin cancer. Now, what about natural ozone depletion? So there are actually areas on Earth where we're going to see natural depletion of the ozone layer, and that's specifically in Antarctica in the spring melt, which are going to form polar stratospheric clouds. Those clouds are made of water and nitric acid, or HNO3, that can form in consistent 100-degree Fahrenheit temperature ranges found above Antarctica. Because remember, the stratosphere is a warmer form of the atmosphere layers. Now, in the presence of those polar stratospheric clouds, chlorine nitrate and hydrochloric acid react and will give off those similar chlorine atoms. That chlorine is photolyzed, which means just simply broken down by the sun into two free chlorine atoms. And remember, we just talked about the chlorine and CFCs are going to break down the ozone. Well, same thing happens here. Those chlorine atoms are then going to break down the ozone, or O3, over and over again into then O2 molecules. So we can see that it is actually in Antarctica where most of the ozone layer is being disturbed. Now, what about reduction in ozone depletion? Well, ozone depletion can be mitigated by replacing those ozone depleting chemicals with substitutes that may not deplete the ozone layer. And that was actually something that we did do. We found a replacement called hydrofluorocarbons, or HFCs. Now, they were the replacement to CFCs, and they actually did help heal the ozone layer, but we found out that HFCs are actually incredibly strong greenhouse gases. So then they are now contributing to climate change. Some other recovery aspects that you need to understand is what was known as the Montreal Protocol. This was an act that was established in 1987 in order to reduce the production of CFCs by half. And this is actually where we started using those HCFCs that don't destroy the ozone but are greenhouse gases. So we saw that the CFCs were banned, but it didn't necessarily solve the problem entirely. It has certainly helped. The ozone layer has healed in some aspects, but most nations did not necessarily follow suit, and some of the propellants were only a small part of the problem. And CFCs actually they spend a very long time in the atmosphere. They don't really break down very well. So although CFCs were banned several years ago, we can actually still find some concentrations of them in the atmosphere now. Now here's just a little practice FRQ. The absorption of solar energy by stratospheric ozone causes ozone molecules to undergo a chemical decomposition and formation. So you have to describe the chemical processes that lead to this natural balance between the decomposition and formation of stratospheric ozone, and you can use chemical equations in your answer. So please, at this point, pause the video and see if you can answer the practice FRQ. Okay, at this point, you should have paused the video, and let's check our answers here. So these were the possible accepted answers that you could have written for the describing chemical processes. So here in the first part, you could say ozone, we know, absorbs UV radiation, producing an oxygen molecule and an oxygen atom. It's then those ozone molecules absorb UV, producing oxygen molecules, or you could have simply just written it as a chemical equation, such as O3 plus UV is going to then photolyze and break it down into oxygen molecules and a free oxygen atom. You could have also said the oxygen molecule reacts with an oxygen atom to form ozone, which is then the formation, and the oxygen molecules absorb UV, forming ozone molecules. All right, everyone, that's the end of this video. You want to make sure that you took notes, and please mark this as done when complete.